We continue the last part of chapter 3, that is 3.5, generation and transmission of electricity. So electricity is generated in power station, transmitted or sent through a long distance cables and then distributed to consumers. So you must just know what is the renewable energy and non-renewable energy. Okay, because renewable energy sources, energy resource that is continually replaced and will not run out. Non-renewable energy resources that cannot be replaced once it has been used. So you can see renewable energy example, hydropower by using water, biomass, solar energy and wind power. Non-renewable, we have fossil fuels, coal, petroleum, natural gas and nuclear fuel. Okay, so I think this one we have discussed a lot in science, lower form. Okay, describe the various way of generating electricity. So electricity is produced using generators. You see, remember we have DC generators and AC generators. A generator has a huge magnet that is turned by a turbine. As the magnet turns inside coil or wire, electricity produced by electromagnetic induction. So this is a very large usage of electromagnetic induction. Many sources of energy are used to turn this turbine. So we have so many examples. You can just go and read yourself. Coal-fired power station. So we have also another example like gas-fired power station using natural gas. We have hydropower, hydroelectric power station, okay, using water. Nuclear power station, so using nuclear fuels, okay, like uranium-235 atoms. Biomass, using rotting plants and agricultural waste such as oil palm kernels and household sewage. Then biomass. Solar, using the light that comes from the sun. Okay. Wind generator, using windmills by using wind. Okay. So all this you can just go and read through all about type of the how renewable energy that you use in order to now next, transmission of electricity. Electrical energy transmitted from power station to consumer using long transmission cables or power line. Electrical energy transmitted at high voltage and use alternating current. A step-up transformer which increases the voltage to as high as 110,000 or 132,000 volt. Okay, step-down transformers used to decrease the voltage before being delivered to the consumers. The long thick cables used as transmission lines are made of copper and aluminium. Okay, so you see the voltage that produced in the hydropower station, for example, is very low. Maybe it's about 30,000 volt only. So when transmit through the power line, we use step-up transformer, increase to 130,000 volt. Okay, and then when reach to the certain place that need the voltage which is lower, we use step-down transformer. So for the transmission line, normally we use low resistance of material like copper and aluminium. Okay, now we want to discuss about energy loss in electricity transmission cable to deduce advantage of high voltage transmission. So the heating effect due to resistance of the cables causes loss of electrical energy as heat energy. When a current flows in a cable, the power loss P through the heating is P equals to I square R, where R is resistance of the cable. So the power loss can be reduced by reducing the resistance and reducing the current, okay, in the cable. So in order to reduce resistance of the cable, a thick cable is used. Example, copper or aluminium. but thick cables are very expensive to install and will be too heavy to be supported securely. So normally it's hang very high up, the transmission cable, so it's not suitable to use a very thick copper wire or aluminum wire, because it's become very heavy and also it's expensive. So the loss of power in transmission of electricity is reduced by reducing current. So this is the method that they use. Okay, reducing current. How to reduce the current? Remember the formula. The power to be transmitted by cables is P equals to VI. I is current in cable, V equals to voltage in the cable. So the current in the cable equivalent to I equals P divided by V, power divided by voltage. This means that current in the cable is inversely proportional to the voltage of cable for certain value of power transmission. So when power transmitted at lower voltage, the current in the cable is large. The greater the current in the cable, the greater the power loss. Meaning if we want to reduce power loss, we need to reduce current. How can we reduce current?